Question 2.40. Some rental cars have a GPS unit installed, which allows the rental car company to check where you are at all times and thus also know your speed at any time. One of these rental cars is driven by an employee in the company's lot, and during the time interval from 0 to 10 seconds, is found to have a position vector as a function of time of r equals 24.4 meter minus t 12.3 meter per second plus t squared 2.43 meter per second squared. So this is the x component of position. I will write this as x. Then the y component is 74.4 meter plus t squared 1.8 meter per second squared minus t cube 0.130 meter per second cube. From this position function, in the first part, we need to find what is the distance of this car from the origin of the coordinate system at t equals 5 seconds. So to find the distance of the car from the origin, we will have to first find what is its x position, y position, and then we can use Pythagorean theorem to find the total distance. So let's write down the x component of position. X is equal to 24.4 minus 12.3 t plus 2.43 t squared. To find the x component of position at time t equals 5 seconds, we will substitute the time value here. So x will be equal to 24.4 minus 12.3 times 5 plus 2.435 squared. And when you solve this, you get the value of x to be equal to 23.65 meter. Now we do the same thing to find the y position. Y component of position is given as 74.4 plus 1.8 t squared minus 0.130 t cube. To find the y position, let's substitute time t as 5 seconds. So we get y equals 74.4 plus 1.805 squared minus 0.1305 cube. That gives you the y value to be equal to 103.15 meter. After we find the x and y component of position at time t equals 5 seconds, we will find the distance covered by using Pythagorean theorem. So we find the distance as r equals square root x squared plus y squared, which is equal to square root 23.65 squared plus 103.15 squared, and you get the distance to be equal to 105.8 meter. In part B of the question, we need to find what is the velocity vector as a function of time. To find the velocity vector as a function of time, we will take time derivative of the position function. So first we will find the x component and y component of velocity and then write them together in vector form. So let's write down the x component of position first. X is 24.4 minus 12.3 t plus 2.43 t squared. You get the x component of velocity by taking the derivative of x. So derivative of a constant, which is 24.4, is 0 because 24.4 does not have t at all. So 0 minus 12.3 remains as it is. Derivative of just t is 1 plus 2.43. Derivative of t squared is 2 times t. So I get the x component of velocity to be equal to negative 12.3 plus 4.86 t. So this is the x component of velocity. We do the same thing to find the y component. To find the y component, we will first write down what is y component of position. It is 74.4 plus 1.80 t squared minus 0.130 t cube. Now we take derivative of y to find y component of velocity. So dy by dt. 74.4 is a constant which is not multiplied with time. Derivative of such constant is 0 plus 1.80. Derivative of t squared is 2t minus 0.13. Derivative of t cube is 3t squared. So we get y component as 3.6t minus 0.39 t squared. So these are the x and y component of velocity. We can write them in vector form as velocity as a function of time equals. First, we will write the x component, negative 12.3 plus 4.86 t. Then we write down the y component, 3.6t minus 0.39 t squared. So this is velocity vector in component form as a function of time. In part C, we need to find what is the speed at t equals 5 seconds. To find the speed, we need to find the magnitude of velocity. And to find the magnitude of velocity, we need to know what is the x and y component of velocity. So we already know the velocity function. We will just substitute the value of time t to find x and y component at time t equals 5 seconds. First, we will find the x component, negative 12.3 plus 4.86 t. Now put t as 5, negative 12.3 plus 4.86 times 5. That gives you the x component of velocity to be equal to 12 meter per second. Then we do the same thing to find the y component. Vy is 3.6t minus 0.39t squared. Substitute time t as 5. So 3.6 times 5 minus 0.395 squared. That will give you the y component of velocity as 8.25 meter per second. After we find the x and y components of velocity, now we can find the speed by taking magnitude of velocity. So we get the speed v as square root vx squared plus vy squared, which is equal to square root 12 squared plus 8.25 squared. That gives me the speed as 14.56 meter per second.